Now, instead of giving values, we can describe these things in terms of z-scores. So what's the probability that z-score is less than 2? Now, if we look back at our chart over here, what we actually notice, so the z-score of the mean is 0. And the z-score of one standard deviation above the mean, remember z-score is the number of standard deviations above the mean. So the z-score of one standard deviation above the mean is 1. And the z-score here is 2 and 3. Similarly, the z-score of one standard deviation below the mean is -1, 2 standard deviations below -2, and 3 standard deviations below -3. So the question is asking, what is the probability that a z-score is less than 2? And we don't actually need to know what the mean or standard deviation is. That information is already in the z-score. It's already included. So what we know, so that's the z-score of 0, 1, and 2. There's a 50% chance of it being less than 0, 34% of it being here, 13.5 of it being there. So 50 plus 34 plus 13.5. And that gives us 97.5%. And the way we would write that is we would say the probability that z is less than 2, so not x, this time it's z, that z is less than 2 is equal to 97.5%. Now, it turns out that let's say the z-score was not exactly on a nice number. Let's say I wanted to know what's the probability that the z is less than 1.5. So it's not as simple as it looks. Wow, that's pretty bad. We'll try that again. Not much better. So what we're going to have is, if this is the mean over here, and so this is the z-score of -1 and 1, and so here the z is 1, and there the z is -1. And remember that the whole thing is 34%. But let's say I wanted to know what is the probability that z was less than 0.5. So I wanted a z-score that was kind of in the middle. And you might think we could chop the 34 in half, but we can't, because if we split this thing in half, clearly this half is bigger than this half over here. So this half is going to be more than 17, and that's going to be less than 17. So what we actually need to do is we need to calculate the area under the curve. And if you remember the equation for a normal distribution, it's a pretty horrifying equation. And to calculate the area under the curve, you need something called calculus. You need integration calculus in particular. And that's not going to work. So what we're going to do instead is we're going to use some pre-marked values. And you can get these type of tables in many areas. If you have one, I would strongly recommend you print it out. You pause the video and print it out right now. I have certainly included one if you're taking my class on the thing. So there's 2 pages for it, and we're going to discuss what this thing means. So what this chart does, so presumably you have the chart now. So let's say I ask a question, and the question is, what is the probability that the z-score is less than 1? So what you're going to do, so this is negative z-scores, so we don't want this one. We want positive z-scores. But notice the picture. What this chart does, this chart gives the probability of being less than the given z-score. So if we want the probability of less than 1, we look up 1 on the left side, and then we want the 100th digit to be 0. And I've already kind of given the answer, but let's see if we see it over there. There's the 1, there's the 0, and then here we have the 0.8413. And so the probability of z being less than 1 is going to be equal to 0.8413. Now, you might be thinking, wait a moment, that's totally not what I said before when I gave these numbers over here, because here was just 84. And this, of course, was just an approximation. This is still an approximation, but it's a much better approximation. So the actual answer would be 84.13%. So let's go, let's do another one. We're probably reading the chart. Again, I've kind of done it. So it's going to be the probability that z is less than 1.32. So the way we do that is we find 1.3 on the left side. The 100th digit is 2, so we go over to 2, and we see where they meet. So 1.3 is over here. We want 0.02 from there, and that's going to meet over there, which is 0.9066. Okay.